Hello everyone. Today we will be discussing a lesson from IGCSE Cambridge Physics, lesson Periodic Table, topic the periodic table. As scientists begin to discover new elements, they needed a way to keep them in order. So in 1869, a scientist called Dmitry Mendeleev first founded this system of the periodic table. Back then, when he invented the system of the periodic table, there were only 63 elements present. But with just 63 elements, he decided the best way to arrange these elements is according to their proton number or the number of protons. So starting from hydrogen, which had only one proton, he arranged the 63 elements that the scientists knew back then. Even with just 63 elements, he was able to predict the different chemical properties of elements that they haven't even discovered yet. So what he did was, he arranged them according to the proton number order, leaving space for the elements that they haven't discovered yet. And today, we have 118 elements, almost double the amount from back in 1869. And still, for this 118 elements, Dmitry Mendeleev's system of the periodic table perfectly fits. Now, when he arranged the elements according to the proton number order, he realized that after a number of elements, the next element has a similar property to one other he saw before. So this is why the periodic table is not just one row of elements. It has rows and columns, such that each column has elements with similar chemical properties. We will learn more about it in the coming slides. Another thing that you need to know about is each column of the periodic table, or we call it a group in the periodic table, has these similar chemical property elements that have some special names. For example, the first group of the periodic table are called alkali metals. Alkali metals are metals that makes alkaline oxides, metal oxides. And the other name that you should remember is group 8, or sometimes you call it group 18 as well, considering these 10 elements. Group 8 or 18 is noble gases. Group 8 consists of noble gases. And group 7 or 17, it consists of halogens. And these yellow metals, the yellow elements they have shown right here, they are called transition metals. Again, we will be discussing about it in a completely different video. As I mentioned before, the periodic table has classified elements and predicted the properties of elements by how it is arranged into this periodic table. The elements that are arranged in the order of proton number, and therefore elements with similar properties, are in one column. Each of these columns have elements with very similar properties. The only exception is hydrogen. This is why you saw in the previous slide that hydrogen is not really put on the periodic table on the first group. It stands in the middle. This is because hydrogen is the only element that is not a metal but produces a positive ion. So the properties of hydrogen is different from the metals in the alkali metal group. The elements in the same periodic group have the same number of electrons in their outer shell. Let's look at group 1. Hydrogen has only one electron. Therefore, hydrogen has only one electron shell, and that one electron rests on the first electron shell. Then we have lithium. Lithium has three electrons. So two of them goes to the first electron shell, and the remaining one goes to the second electron shell. So even lithium has only one electron in its outermost shell. Then let's look at sodium. Sodium has 8 electrons. So two of them would go to the first electron shell. 8 of them will go to the second electron shell. And the remaining one moves on to the third and last electron shell. And if you check for every single element that is in the first group, you will notice when you draw the electron configuration, the last energy levels will always have one electron. The chemical properties of any element is decided by the number of electrons in the last energy level. Shall we recall why that is? This is because chemical properties refer to how atoms bond with other atoms. How do they make bonds? And what is the bonding electron? Or what are the bonding electrons in an electron configuration? It's always the electrons in the last energy level. Only the electrons in the last energy level will participate in bonding. So bonding, or the nature of bonding of atoms, depend on the number of final shell electrons. Therefore, the chemical properties also depend on the number of final shell electrons. This is why that elements in the same group have same chemical properties or similar chemical properties. Not only that, there is a significance in the row number of each of these elements, just like how the group number gives us some very important piece of information, which is the number of final shell electrons. Even the row number, and a row is called a period. Okay, just like how a column is called a group, a row is called a period. This period number also gives us a very important piece of information. It gives us the number of electron shells of that particular atom. For example, let's look at the first group again. Hydrogen, like I said, has one electron, and therefore one energy shell is enough. Then lithium has 3 electrons, so 2 of them goes to the first one, and the last one goes to the second one. Then there's sodium. Sodium has 11 electrons, 2 in the first, 8 in the second, and 1 final electron in the last. And potassium has 19 electrons. Here, 2 in the first, 8 in the second, another 8 in the third. That one is also completely full. And the one final electron on the fourth energy level. So if you look at it, since it's group 1, all of them has 1 electron in their final energy shell. But there's another pattern you can see. Hydrogen is in row number 1. So hydrogen is from period 1. So it has only 1 energy level. Lithium is in period 2, or row number 2. So it has 2 energy levels. Sodium is in row number 3, which means period 3. Therefore, it has 3 energy levels. And finally, potassium has 4 energy levels, which means it is in the 4th row, or the 4th period. So it's important to know that this periodic table pattern is so fascinating that it gives us so much information about a single element just based on its position. The position, or the group number and the period number, says the number of energy shells it has and also the final shell electrons it has. Now that we have covered the theory for this topic, let's look at a few past paper questions. Which of the following options is a classification method in the periodic table? Period, group, blocks, all of the above. Of course, we know period is classified as a row of a periodic table. A group is a column of a periodic table. A block is the different colored blocks in the periodic table, if you could remember. Like the first one we had in a different color because they are alkaline metals. The last one we had a different color because they are noble gases. Then we had transition metals in the middle. We had halogens. So yes, blocks are also a classification method. So the correct answer for this should be all of the above. So not just the periodic trends and how the periodic table is formed that you need to remember. You also need to remember symbols and the names of each element, at least the main elements, the ones that are very commonly discussed, especially the first 20 elements and some of the transition elements. Now, out of these elements in the periodic table, some of them are from the ancient times. So they have Latin names. Almost 30 elements in the periodic table are derived from their Latin name. So if you have elements that start with letters that doesn't really match with their names, that's probably because the periodic table letter came from its Latin name and not the English name. So this question is an example for that. Which element has been given the Latin name natrium? So just look at the answers given here and try to recall the symbol of each of these elements, and then you can come into this conclusion very soon. Nitrogen has a symbol just N. Aluminium has a symbol Al. They seem to have the symbols coming from the English names. Then potassium has a symbol K. There is no K in the English word potassium. So potassium is also derived from its Latin name, which is kalium. And sodium, what is the symbol for sodium? Sodium is Na. So now it's quite obvious which element came from its Latin name, natrium. It's in fact sodium. Sodium's symbol is Na because of its Latin name, natrium. Finally, let's look at another such question. Which option relates to the element and its respective symbol? We have chlorine, nitrogen, and potassium. Chlorine symbol is coming from its English word chlorine, English name chlorine. So chlorine will have the symbol Cl. Why not C? Because carbon was found much before chlorine. So carbon already took the C. C is actually carbon. The nitrogen also is derived from its English name nitrogen. So it has the symbol N. Why not Ni? Because nitrogen was the element that they found first. So they found another element that has a name that starts with Ni, which is nickel. So nickel got the symbol Ni instead of N. Then we have potassium. Now, potassium, although starts with letter P, potassium was found much before, and it was not named potassium, it was named kalium in Latin. So instead of having the English letter P, potassium got its name, potassium got its symbol from its Latin name, kalium. So potassium has a symbol K and not P. P is in fact phosphorus and not potassium. So the correct combination is given by the answer A, chlorine, nitrogen, and potassium. So answer is answer 1A. With this, we have come to the end of the discussion of this topic. Thank you for listening.